Hey friends, APIs are the foundational building blocks of modern applications, and in today's world of API driven development, your APIs are often spread across on premises and multi cloud environments. Now you can use a self hosted gateway in Azure API Management on your infrastructure to control, secure, and operate your API in a consistent way. Tom Kerkhove is here to show me how today on Azure Friday. Hey friends, it's Azure Friday. I'm here with Tom. How are you, sir?
Thank you. I'm doing fine. How are you?
I am excited to talk to you and excited to learn about Azure API Management, which I have talked about before, except not self hosted. I actually don't know how that would be possible. You've got a software as a service that I've always thought of as being some of the secret sauce of Azure, and now I can host it anywhere. I'm fascinated to learn how you made that happen.
Yeah, I'm happy to bring you that gateway closer to where you want to use it.
All right, let's hear about it. I understand you have a slide to give me a sense of how this fits together.
Yes. So if we have a high level view of API management, there's three main components. We have the developer portal where app developers can explore, try, and use the APIs. Uh, we also have the management plane where you can basically author the APIs you want to expose to who you want to expose it, etc. And then we have the heart of API management, which is basically the API gateway. So we have a couple of options for these gateway where you can use a consumption gateway, you can have a PaaS gateway, and you can also now run this as a self-hosted gateway where you basically want to run it. So if you have a closer look at the cloud-based approach, is you basically spin up an API management instance, and all your app users or integrators talk to the gateway in the cloud, which then connects to the various backends. However, in certain situations, you do not want to call Azure to go to, let's say, another cloud or an on prem system. Instead, what we do is we allow you to bring the gateway closer to where your applications are so that you can reduce the latency, increase the security, etc., while still using API management because it is a federated solution. So you still author everything on API management, but then these gateways connect and synchronize, serving the latest configuration on your local infrastructure. So it is
Interesting.
not
Okay,
a
so
fully disconnected solution.
So this brings location transparency to it, but also control of exactly what gets in and out of my network. I have absolute control now.
Yes, correct. So if you're running completely on-prem and traffic cannot go outside of that boundary, you can use our self-hosted gateway so that you still can benefit from our API gateway without exposing it to the public internet.
So if you can self-host this, probably you've containerized the entire product or a portion of the
Yes.
product. That must mean that you could self-host that gateway like on your laptop as a developer.
Yes, so that's also a big plus for your developer experience is instead of always talking to the cloud, I can now spin up a gateway, I can apply a policy on the cloud and basically have that propagated to my machine and integrated in your local testing as well. So it's a lot simpler now to test your policies and changes locally.
Wow, I would love to see that.
Yeah. So uh, one of the benefits is that because it's a container, you can basically run it anywhere. You can run it in Docker. You can run it on Kubernetes. You can run it on VMs with Docker. You can even run it on as a container on top of AKS, which we will see as well. So as you mentioned, it is a Docker image. It is only for Linux and is available in the Microsoft Container Registry. And the only requirement that we have is that it needs to have an outbound connection to Azure, which should be fairly easy to set up from a security perspective so that it can pull down the configuration and send telemetry to the cloud if you want, because that is optional. It's also good to point out that if it loses the connectivity to the cloud, your requests will not stop working. Your gateway on prem or wherever it runs, be it on the ship even, it will still work, but it will not have the latest configuration. So there's no risk on having an outage because it lost connectivity.
You say that it only needs outgoing connectivity. This may be an ignorant question on my part, but is there some kind of VPN or mesh that is running on this? I mean, how are you able to do that over just one port outgoing?
Yeah, so basically the gateway is just talking to our configuration API and checking are there any changes or not.
I
If
see.
there are, it is receiving them and processing them.
Okay.
We don't have a connection from the cloud because of security as well. Yes.
Right. So then it is truly self-hosted. So it bootstraps itself with that outgoing connectivity for the
Yes.
config, and then it's just running. It's just a piece of Azure in your infrastructure that you control.
Correct. Yes.
That's brilliant. I love it.
And there's more. We also have, with this gateway, support for Dapper. So we have Dapper policies so that if you have it running, for example, on Kubernetes or Azure Container Apps, you can talk to these Dapper applications without having to know what Dapper is. You just use one of our policies and it basically just works. And this is also an example of a small difference between the cloud and self-hosted is there is not 100% parity. There are differences, but we're trying to close the gap as much. For example, Dapper is one. We also have open telemetry metrics for the self-hosted gateway because you have to run it, so you also have to operate it. And we want to give you that transparency on how is the gateway doing.
All right. Well, this makes it clear how it's supposed to work. I'd love to see it work.
Yes, I agree. Talk is cheap, so let's go to Azure. So I have here a pre-provisioned API management instance, which is a premium tier. You can also use developer tier where you have self-hosted gateway. Now I have some pre-created APIs here on the left where we will use the products API, which is just returning fixed set of JSON payload. So if you have a look, it is talking to a monolith API on web apps, which is great. So actually, what it does is it has a get products API where for today we want to get rid of this monolith. So even before we introduce self-hosted gateway, we will do some traffic splitting between the monolith and the future backend, which runs on Kubernetes. Later on, we will then run the self-hosted gateway on that Kubernetes cluster instead. So how do we do this? So in API management, you have the policies which allow you to basically extend your API traffic. And in this case, we will split the traffic in a 50-50 fashion. So here I have a policy where we generate a random URL ID, which is basically 1 or 2, which is to generate a 50-50 split. If the value is 1, we will not do anything and use the default backend. If it is 2, we will basically say, hey, switch the traffic and send it to this other backend service, which points to a backend entity in API management, which is called Products API on Kubernetes. So if I save this, I can now talk to this managed gateway by using the nice test experience here. And if I click send, we will get a response back. And you can already see that there is some additional headers that I added based on the context properties that we have. For starters, we can see this is the managed gateway because there's no self-hosted yet. This instance is running in North Europe, and my API management service is this one. And the upstream URL is the monolith. So in this case, I'm in the first bucket. If I do the call again, I am in the same bucket. If I do the other call again, it fails. So this is not intentional, but this shows that it is talking to the other API. Now, while this is not intentional, I can now also show that we have the trace capabilities, which help you troubleshoot these issues. So if I do another request with the trace here, if we get a request to the other backend, we should see why it is failing. And here we can basically see the whole pipeline that the request went through. So we can see that it got the request, and I will skip ahead where it is basically generating the value. So here it is 1, and it is going to here send the request to the monolith. So this request was successful. So if I do it again, we will now see that hopefully it went to the second backend here. We will now also see why it failed. This is why I am curious, because this is not expected to fail. So we see it successfully changes it to my um, backend on Kubernetes, and I can already see that it is using the local Kubernetes DNS, which is why it is failing. I will skip the fix for the sake of the demo, but you can already see that it is switching the traffic successfully, and we can add some headers to basically split the traffic. Now, if we want to run this gateway ourselves, we can go to a new resource in API management, which is called Gateway. So here you can create a gateway which you can then self-deploy. So I already created one, which is called Azure Friday, and the location is Belgium because I live in Belgium. And this is where it becomes interesting. Here we have dedicated metrics just for this single gateway, which are the same as for the managed gateway. You can also see that I did some testing earlier today, and I was doing a fairly nice amount of requests. We have the duration, etc. And then the interesting point is deployment. So all you need is a gateway token and a link to the configuration endpoint. And actually, at Build, we also released AD authentication. So instead of having this gateway token, you can now also authenticate with an Azure AD or Entra application as well. And then we provide some nice deployment examples to get started. So, Scott, you asked about running Docker image locally. So let's just do it. So I can basically copy this snippet, and I can go to a new command line, and I can basically just save that to a local file. So let's do .conf, which I already have open. So let me go here, save this, and .conf. Let me copy the path so that I don't forget. Then you can just come back and copy the Docker command. We will use different ports. So let me go with, 8080, right? And then let's get rid of the second port, give it a name.
Maybe you can control scroll and make
Yeah.
that just a smidge larger. There we go.
So I'm just
Gotcha.
running a regular docker run command, which is going to spin up this image. And if you check the logs, you you can see
Logs,
that I
plural.
made a typo.
No, it's
Yes.
all cool. Happens to the best of us.
So as with every Docker image, you have to
Oh,
have
wow.
ASCII art. So that's where we start. And then you can basically see the whole process of this gateway starting up, exposing some endpoints for synchronization locally, and then it's connecting to the configuration API. And you can basically see which policies are available, etc., etc. You can see anything that the gateway does. So now we have this up and running. I can just talk to it. So I already have this ready. So here I am talking to local hosts 808099, and I can just hit send. I have an API key here and I get a response. I also get the same headers that I had from the cloud, but now you can see that instead of managed, it is not managed. I can
Mhm.
see the region is Belgium and I get the gateway ID, but I am still talking to that cloud backend.
That's so cool. So at this point here, you can do anything, right? Like it's just
Yes,
another container, part of your orchestration. You could run
correct.
your telemetry collectors, you could run Prometheus, you're a member of the team.
Yes. So what we actually do ourselves when we work on the self-hosted gateway is we also run it on as a container, and we use Docker Compose. So we also spin up Prometheus OpenTelemetry collector, Dapper apps, just with one command, which is really super nice as a developer. Another thing to also point out is that by default, it does not expose any APIs. You basically have to opt in for the APIs that you want to expose. So this basically gives you, as an API admin, control on which gateway is deployed where and what is allowed to be exposed as well, which is also important for security. Now, this is nice. Docker is fine for local development, but what if we use Kubernetes? For Kubernetes, we also give you a YAML file that you can use, but let's not jump through hoops. Let's just make it simple and use Helm. So we also have an open source Helm chart, which you can just deploy with this one command, which is already pre-populated for you. We have various knobs for you to turn if you want. And once you're ready, you can just deploy this to your cluster. So I already went ahead and deployed this. So we're no longer in Docker land. So kubectl get all. And you will see that when you install it, by default, it already creates 3 pods to ensure you're highly available. It installs the service for to basically talk to it, and also a discovery endpoint, which is when you run multiple instances, they can synchronize the rate limit information, etc. And this is what we install: just one deployment, 2 services, and you're also good to go. So in theory, if you do a kubectl logs, you will see the same log style. It's the same logs basically, and you can now talk to this gateway in the cloud. And actually, I have some other tricks to show for the policies, because we were still talking to that cloud backend, but instead we want to talk to the local API that's running on Kubernetes. So we used to do this 50-50 traffic split, but what we'll do now is we will basically change the logic so that, oops, I clicked save too fast. So instead, what we basically do is we use this context property, which basically says, if I'm talking to the cloud, I want to use the default, which is also based in the cloud. If I'm talking to the Kubernetes workload, which is managed, I will switch to the Kubernetes workload, which is using the Kubernetes DNS and sending traffic inside the cluster, so that we don't go outside of the cluster and come back in. We reduce the network, etc. So I have here a similar request, which is just a Kubernetes service exposed through a load balancer on Kubernetes. I have the same API key, and I hit send, and I get a response back. We can see it's also the same gateway ID, it's not managed, etc. But the interesting point is here. So if you're familiar with Kubernetes, you will recognize that this is a local Kubernetes DNS entry that just talked to the service in another namespace.
Right. You're
So
cluster.local here. You're using internal DNS.
correct. So if I would go back now to the cloud, here you will see that it keeps talking to the cloud one.
Right.
And
Managed North Europe is managed
correct.
as true.
Correct. So this shows that you can basically shift your traffic also based on the gateways that you have. While Kubernetes is great, why do you need to basically host your own cluster, deploy apps, infrastructure, etc.? If you don't want to do that, you can also run the same API gateway on Azure Container Apps, so that when your apps are integrating, you can do that over an API gateway as well. So I also have a container app created, which is already running our self-hosted gateway. And as part of that, I have Dapperized the gateway, meaning in container apps, it is using Dapper with an app ID and an app port. And on my container app environment, we also have a pub/sub component. So what we will now do is for every request, we will basically check which gateway am I talking to, because this has another gateway ID than the one on Kubernetes. If it is the one on container apps, we will also use the Dapper policy to queue a message. And if it is talking to Kubernetes, we will just only talk to the API. So I have this ready already here. And let me deploy this policy. So as I mentioned, there's a couple of things here. First is we're checking, are we using a managed gateway or not? If not, then we check what the gateway ID is. If it is Azure Friday, that is the one that runs on our Kubernetes cluster. And then we basically apply a header and we change to the backend that we were already using. If we are on container apps, we are changing to another API, which is hosted on container apps. We add the header, and then here we basically use a Dapper policy to send a message to a pub/sub component, and the topic name is products_request. And as part of that body, we basically just add the subscription that I use to authenticate. So
So
if I
then
click
once that
save,
context is in there, you've got all the information that you need to move this
correct.
however you want.
Yes, so we have a nice documentation page, so you get access to the user, to the groups, to the API product, basically anything in the context of that request. So if I go here, this is my container app, which is running our API gateway. And if we click send, you can see similar things where I have the upstream header, the upstream URL, which is another container app. And you can also see, the Dapper header is not here. But you basically can also get access to the response from Dapper and send that in the request as well, or your telemetry or whatever. So if I send a couple of requests, this is going to queue messages for us, which we will then find here on our service bus. So if I do a receive, you will see that as part of this policy, it has just queued them by using Dapper. And I didn't have to know how to do all of that. Just say publish to this pub/sub component, and we're good to go. So
Very
this,
cool. I help me understand. This is available now. People can sign up right away. Can I? I
correct.
mean, I'm already using API management. Can I just start using it self-hosted?
Correct. Self-hosted is GA. You can just get started. It costs $1,000 per gateway resource, and you can scale to as many instances as you want. So it's fairly cheap to do that, but you have to manage the infrastructure.
Right. Okay. And then all this flexibility that you've shown me, whether it be Dapper integration, other things that we've talked about but haven't seen, like metrics and Open Telemetry Collector and Managed Prometheus, all available to us once we're set up.
Correct. Everything's ready today. And I didn't show it yet, but if you're also using Application Insights, the same app map functionality is available. So you'll see all your various gateways and how they integrate with the various backends that they have.
Very cool. Well, folks are going to be able to check all of that out in the docs. We've got links in the show notes on various topics on the comparison between managed and self-hosted, and all of the things that Tom has shown us, and a few that he hasn't yet. Thanks so much for spending time with me today.
Thank you very much for having me.
All right, this has been another episode of Azure Friday. I'm learning all about managed APIs and Azure API Management's self-hosted gateway today on Azure Friday. Hey, thanks for watching this episode of Azure Friday. Now I need you to like it, comment on it, tell your friends, retweet it. Watch more Azure Friday.